Welcome to Still Science Lab. Tonight, we are stepping into the microscopic fog to ask a question that challenges the very foundation of our existence. A question that sounds deceptively simple, yet hides a depth that could swallow galaxies. What is an electron actually made of? It is the ghost in the machine of our reality, the architect of every shape you have ever seen and every texture you have ever felt. Before we can understand the internal anatomy of this fundamental particle, we must first confront a truth so unsettling that it changes the way you look at your own hands. We must dismantle the greatest lie our senses have ever told us, the lie of solidity. Right now, as you listen to my voice, you might be holding a phone in your hand. You feel its weight, the cool smoothness of the glass, the hard edge of the casing. Or perhaps you are sitting in a chair, feeling the fabric against your back and the floor beneath your feet. Your brain is giving you a very clear, very persistent report. It tells you that you are in direct contact with the world. It tells you that there is no gap between your skin and the objects you interact with. It tells you that matter is touching matter. But tonight, we must recognize that your brain is a storyteller, and in the case of touch, it is telling a fairy tale. The truth is far more strange, far more wonderful, and perhaps a bit lonely. The truth is that you have never truly touched anything in your entire life. To understand why, we have to travel down into the scales where the laws of our daily life lose their meaning. If we were to zoom into the place where your finger meets the screen of your phone, we wouldn't see two solid surfaces merging. Instead, we would see a chaotic, frantic landscape of energy. Every atom in your body is surrounded by a cloud of electrons, negative charges that are constantly in motion, existing in a state of perpetual elsewhere until they are forced to interact. The atoms of the phone are the same. As you move your hand closer to the object, the electron clouds of your skin begin to overlap with the electron clouds of the device. But electrons are not friendly neighbors. They are all negatively charged, and in the world of electromagnetism, like charges, repel each other with a ferocity that is almost unimaginable at such small distances. This is called electrostatic repulsion. It is a fundamental law of nature. As the gap between your finger and the phone narrows to a few nanometers, billionths of a meter, this force becomes so immense that it stops you in your tracks. It is an invisible, unbridgeable chasm. No matter how hard you press, no matter how much strength you exert, you can never overcome that final, microscopic distance. You are currently hovering. Every part of your body that seems to be resting on the world is actually floating on a cushion of invisible force. You are levitating nanometers above your chair. You are floating nanometers away from the person you love when you hold their hand. There is always a gap, a silent vacuum that keeps you isolated from the rest of the universe. So, if we are not actually touching, what is that sensation we feel? Why does the world feel so convincingly solid? What we interpret as touch is actually a warning signal from the deep structure of reality. It is the result of your nervous system interpreting a clash of force fields. When the electrons in your skin get too close to the electrons in another object, they begin to scream at each other in the language of physics. They push back with such violence that the atoms in your skin are slightly distorted. This distortion triggers nerve endings, which send an electrical pulse to your brain. Your brain, which has no way of seeing the microscopic gap, translates this signal into the feeling of solid. It creates the concept of texture, pressure, and resistance to help you navigate a world of forces. Touch is not a physical merging. It is the feeling of being rejected by the matter around you. This rejection is what prevents you from falling through your chair. It is what keeps the floor from swallowing you up as you walk. We think of the ground as a solid foundation, but it is actually a massive collection of electromagnetic barriers. We are ghosts drifting through a world of invisible walls. The only reason we don't pass through walls like spirits is because the electrons in the wall are adamant that they will not share their space with the electrons in our bodies. This is governed by a principle so strict that it defines the very shape of the universe, the Pauli exclusion principle. It states that two electrons cannot occupy the same state at the same time. They are the ultimate introverts of the subatomic world, demanding their own personal space and enforcing that demand with the strongest force they have. When you press your hand against a pane of glass and feel that cool, smooth resistance, you are experiencing a masterpiece of quantum engineering. You are feeling the collective refusal of trillions upon trillions of electrons to let you pass. You are feeling the tension of the universe itself maintaining its boundaries. This realization can be overwhelming. It makes the world feel fragile, as if we are all walking on thin air because, in a very literal sense, we are. But there is a profound beauty in this isolation. The fact that we are separated from the world by these force fields is exactly what allows for the diversity of forms we see. Without this repulsion, without the electron's fierce protection of its territory, matter would have no structure. Atoms would collapse into each other. You would collapse into the earth, and the earth would collapse into the sun. The universe would be a featureless, dense soup of particles with no distinction between you and the chair, between the sea and the sky. The electron is the guardian of the between. It is the particle that says no so that yes can exist. It creates the boundaries that allow for shape, for color, and for life. When we ask what an electron is actually made of, we are asking about the nature of this guardian. We are asking about the source of the force that holds us apart and, in doing so, holds us together. We spend our entire lives believing in solidity and contact, yet we are phantoms navigating a landscape of energy. We are made of star stuff, forged in the nuclear furnaces of ancient suns, and yet we are held together by the tireless dance of these invisible, frantic ghosts. As we stand here, lurlung in the void of our own atoms, we begin to see that the world is not a collection of things, but a collection of events and interactions. The solid desk is an event, a constant, high-speed interaction of electromagnetic fields. Your body is a long-running symphony of these same interactions. Every moment of your life is a miracle of physics, a delicate balance where the force of gravity tries to pull you down into the center of the planet, and the tiny, massless electron stands its ground and says, "This far and no further." If touch is an illusion, it is perhaps the most important illusion we have. It is the bridge between the cold, abstract laws of physics and the warm, felt experience of being alive. It is the brain's way of making sense of a universe that is fundamentally ungraspable. We live in the gap. We exist in the nanometers of space that the electron refuses to give up, and it is within that gap that we find our individuality. Our separateness is not a tragedy. It is the condition for our existence. This evening, as we move deeper into the heart of the atom, remember this feeling of levitation. Hold on to the realization that the world is far less solid and far more mysterious than it appears. The electron, this tiny point of charge that we are about to dissect, is the reason you can stand, the reason you can see, and the reason you can wonder. It is the smallest part of the story, but it is the one that makes the story possible. Tonight, we look past the illusion. We look past the warning signals of our nerves. We look inward, and we look upward to find the truth hidden in the center of the storm. We are travelers in a vast, energetic ocean, and the electron is the vessel that carries us. Now, let us find out what this vessel is built from. To look at the world around us is to witness a magnificent deception, a seamless illusion of solidity and continuity that our brains construct to help us navigate reality. When we gaze upon a mountain, a steel beam, or the hand of a loved one, we perceive these things as absolute, filled, and substantial. We trust the evidence of our eyes and the feedback of our fingertips, believing that matter is a continuous fabric, dense and uninterrupted. However, this perception is fundamentally wrong. If we could strip away the comfortable veneer of the macroscopic world and plunge into the subatomic architecture that underpins it, we would not find a brick-and-mortar reality. Instead, we would find ourselves staring into a terrifyingly vast, silent, and empty abyss. The deeper we go, the less we find. This is the architecture of nothingness. To truly grasp the staggering scale of this emptiness, we must descend from the world of meters and centimeters into the realm of the angstrom. Imagine for a moment that we have the power to magnify a single atom of hydrogen until it becomes the size of a modern football stadium. In this colossal arena, we might expect the components of the atom to fill the space, like gravel filling a jar or water filling a pool. We might expect a chaotic, crowded environment. But as we stand on the imaginary grass of this atomic stadium, looking for the substance of matter, we are greeted only by a haunting emptiness. In the very center of the field, resting on the 50-yard line, sits the atomic nucleus. In our expanded scale, this nucleus, which contains almost 99.9% of the atom's mass, is not a giant boulder or a massive machine. It is the size of a small marble. That is it. That tiny glass sphere, sitting alone in the middle of a vast stadium, represents the stuff of the atom. It is the anchor, the gravitational heart. Now we must ask, where is the electron? If the nucleus is the marble in the center, is the electron circling the bleachers? Is it in the first few rows of seats? No. To find the electron in this analogy, you would have to leave the field, leave the stands, and go all the way out to the farthest edge of the stadium parking lot, or perhaps even the city limits. The electron would be a speck of dust, smaller than the head of a pin, whizzing around that distant perimeter. Between the marble in the center and the dust mote on the edge, there is absolutely nothing. There is no air, no fluid, no scaffolding. There is only a void so complete and so vast relative to the particles themselves that it defies human comprehension. The atom is a cathedral of empty space, a vast, hollow shell where the walls are miles away from the altar. This is not a unique feature of hydrogen. It is the blueprint of everything. The iron in your blood, the calcium in your bones, the carbon in the diamonds buried deep in the earth, they are all constructed with this same ghostly architecture. Science tells us that atoms are roughly 99.9999999% empty space. To say that matter is mostly nothing is a drastic understatement. It is almost entirely nothing, with only the faintest suggestion of something dispersed within it. It is a ghost town where the houses are light years apart. The solidity we feel is not derived from the density of the particles, but from the ferocity of their movement and the strength of the force fields they generate. The electron, that distant speck of dust, moves with such frantic speed that it creates a shell of influence, a barrier that prevents other atoms from encroaching. It is like a fan blade spinning so fast that it appears to be a solid disk. If you throw a rock at a spinning fan, it bounces off, not because the fan is a solid wall of plastic, but because the speed of the blade defends the empty space between the blades. Similarly, our bodies are comprised of these spinning, orbiting entities that defend their internal voids with electromagnetic force. We are not solid, we are merely energetic. To visualize the sheer extent of this emptiness, we can perform a mental experiment of compression. Suppose we played the role of a cosmic trash compactor. Suppose we could somehow turn off the electromagnetic forces that keep the electrons far apart from the nuclei. Suppose we could squeeze all the empty space out of the atom, collapsing the electrons down until they smashed into the nucleus, eliminating that vast stadium of nothingness and leaving only the raw physical material. If we performed this procedure on a single human body, removing all the void and leaving only the actual subatomic matter, that person would no longer be 6 feet tall. They would not even be the size of a mouse. The entire physical substance of a human being, stripped of its empty space, would shrink down to a particle smaller than a grain of salt. It would be a microscopic speck, invisible to the naked eye, yet it would still retain the entire mass of the human being. It would be a speck weighing nearly 200 pounds, dense beyond imagination. Now, let us expand this thought experiment to the entire human race. Consider every living person on Earth today, all 8 billion of us. Imagine the sheer volume of humanity, the crowds in Tokyo, the bustling streets of New York, the rural villages of India, the stadiums filled with spectators. Think of the physical space we occupy, the height, the width, the volume of 8 billion bodies. Now, apply the same compression. Remove the empty space from every single atom in every single person on the planet. Collapse the stadiums. Bring the distant electrons crashing into the marble nuclei. The result is humbling to the point of absurdity. If you removed the empty space from the entire human species, all 8 billion of us would fit inside the volume of a single sugar cube. Let that sink in. The entirety of human biology, every heart beating, every brain thinking, every hand reaching out, compressed into a block of matter no larger than a piece of candy. And yet, that sugar cube would be monstrous. It would not weigh a few grams, because it still contains the mass of 8 billion people. That single sugar cube would weigh approximately 500 million tons. It would be incredibly heavy, instantly falling through the table, crashing through the floor, piercing the crust of the earth, and sinking all the way to the planet's core, pulled down by its own impossible density. This form of matter, where the empty space is crushed out, is not merely science fiction. It exists in the universe. We call these objects neutron stars. They are the corpses of giant suns that have collapsed under their own gravity, squeezing out the atomic void until they are nothing but pure, dense nuclei. A neutron star is essentially a city-sized atomic nucleus. It is a glimpse of what matter looks like when the architecture of nothingness is demolished. But here on Earth, in the gentle conditions of our daily lives, the void remains intact. We walk through life assuming we are substantial entities, but in reality, we are walking clouds of probability, sparse mists of particles held together by forces rather than fullness. The reason you cannot walk through a wall is not because the wall is full of matter and you are full of matter. It is because the electromagnetic fields of the wall's empty atoms repel the electromagnetic fields of your empty atoms. It is force pushing against force, void pushing against void. This realization forces a profound shift in perspective. When we look at a starry night sky, we are often struck by the vast emptiness of outer space, the millions of miles of nothingness between the planets, the light years of silence between the stars. We think of space as something that is out there, separate from us. But the physics of the atom reveals that this vast emptiness is not just above our heads, it is inside us. It is us. The inner space of our own bodies is just as vacuous, just as spread out, and just as dominated by the void as the galaxy itself. We are, in a very literal sense, microcosms of the universe. The ratio of matter to space in an atom is strikingly similar to the ratio of matter to space in the cosmos. We are mostly empty space, structured by invisible laws, masquerading as solid objects. The material world is a trick of the light, a density of energy fields rather than a density of stuff. If we were to look at a human body with eyes that could see only the atomic nuclei, the only parts of us that have significant mass, we would not see a person. We would see a vague, ghostly shimmer, a faint mist of dust motes hovering in the shape of a human, virtually transparent, mostly non-existent. The fact that we feel solid, that we can hug, hold, and build, is a testament to the power of the forces that bridge this abyss. We are built upon a foundation of lack. The architecture of nothingness is not a flaw in the design of the universe. It is the canvas upon which the painting of reality is spread. It creates the necessary room for vibration, for motion, for chemistry, and for life. Without this emptiness, without this vast separation between the core and the edge, the dynamic dance of the universe would freeze. We are hollow, and yet it is within this hollowness that the complexity of existence resides. Our minds are architects of geometry. From the moment we open our eyes as infants, we learn to understand the world through shapes and boundaries. We grasp a ball and understand it is round. We touch a block and understand it has edges. We look at a mountain and perceive its massive volume. Our entire neurological framework is built upon the assumption that to exist is to occupy space. If something is real, it must have a top, a bottom, an inside, and an outside. It must have dimensions, height, width, and depth. This is the intuitive logic of the macroscopic world, a logic that has served us well for survival and engineering. However, when we embark on the journey to find the ultimate building block of that reality, the electron, this logic does not merely fail, it dissolves entirely. We are forced to confront a concept that is mathematically sound yet philosophically maddening: the dimensionless point. As we continue our descent into the subatomic realm, leaving behind the vast, empty cathedral of the atom's void, we approach the electron itself. Having accepted that the atom is mostly empty space, we now seek the solid anchor, the bit of matter that actually performs the work of the universe. We expect to find a thing. In our textbooks and popular imagination, the electron is almost always depicted as a tiny, shiny sphere, a miniature planet orbiting the sun of the nucleus. We imagine that if we could just build a microscope powerful enough, if we could zoom in with infinite precision, we would eventually see this sphere looming large. We would see its surface, perhaps textured or smooth. We would be able to measure its circumference. We would be able to point to its equator and its poles. We instinctively believe that the electron is simply a very small marble. But the standard model of particle physics, the most tested and precise theory in the history of science, shatters this image. It tells us something that the human brain struggles to compute. It asserts that the electron is not a sphere, it is not a blob, it is not a compressed nugget of matter. The electron is a point particle. In the rigid language of geometry, a point is a specific concept. It is an entity with 0 dimensions. It has no radius. It has no volume. It has no surface area. It has no spatial extension whatsoever. To understand the gravity of this statement, we must strip away our mental habits. Take an orange and shrink it. It becomes a pea. Shrink the pea, and it becomes a grain of sand. Shrink the grain of sand until it is invisible to the naked eye, and it becomes a microscopic speck of dust. But that speck of dust still has a top and a bottom. It still occupies a specific amount of room in the universe. If you were small enough, you could walk across its surface. The electron is different. The electron is not just very small, it is infinitely small. It is the end of the line. It is a coordinate in space that possesses physical properties but lacks a physical body. If you were to try to measure the radius of an electron, the answer would not be a very small number like 0.000000000001. The answer would be 0. This leads us into a profound paradox. We know the electron exists. We know it has mass. It weighs something, even if that weight is incredibly slight. We know it has an electric charge. It pushes and pulls against other particles. We know it has spin, a form of angular momentum. In our classical world, for something to have mass, it must have density, and density requires volume. For something to have charge, that charge must be spread across a surface. For something to spin, there must be a physical object rotating around an axis. How can a geometric point, which has no size, possess weight? How can a 0-dimensional speck rotate? If it has no radius, there is nothing to spin. The electron, therefore, acts like a mathematical ghost. It is a bundle of distinct physical attributes pinned to a location in space. Yet it lacks the one attribute we associate with reality: size. It is a here without a there. It is a singularity of data. When physicists calculate the interactions of particles, they treat the electron as a mathematical point because that is exactly how it behaves. If the electron had a radius, even an incredibly tiny one, it would imply that the electron has an internal structure. If it were a ball, it would have a left side and a right side. It would have a center and a crust. And if it had parts, hypothetically, those parts could be separated. The ball could be smashed open or crushed. However, in over a century of smashing particles together in colossal accelerators, subjecting electrons to violence and energy levels similar to the Big Bang, we have never seen an electron crack. We have never seen it dent. We have never seen electron debris fly out from a collision. Protons, which live in the nucleus, are different. They have a size, and when we smash them, we see the quarks inside them. Protons are composite. They are bags of smaller things. But the electron appears to be fundamental. It cannot be divided. It has no insides to reveal. The only way for an object to be truly indivisible, to be impossible to break apart, is for it to have no parts. And the only way to have no parts is to have no size. The electron is an armor of 0 dimensions. It is indestructible precisely because there is nothing there to break. This concept of the point particle forces us to rethink the nature of the material world. If you hold a steel bar in your hand, you perceive it as a solid, continuous object. We know it is made of atoms, and we know atoms are made of electrons and nuclei. But if the electrons which are responsible for the volume and chemical bonds of the steel are themselves dimensionless points, then the solidity of the steel is an illusion generated by the behavior of ghosts. The stuff that makes up the steel effectively occupies no space at all. The mass of the electron is squeezed into a volume of zero. In classical physics, this leads to a terrifying conclusion: infinite density. If you take any amount of mass and divide it by zero volume, the result is infinity. This is a singularity, the same mathematical nightmare that exists at the center of a black hole. Yet, every single electron in every atom of your body is, technically, a micro-singularity. We attempt to visualize this by imagining a map. Stick a pin into a map to mark a city. The hole the pin makes has a size, but the coordinate itself, latitude 40, longitude 73, has no size. It is just an address. The electron is like that address, but it is an address that can push you. It is a coordinate that carries a force field. When we bump into an electron, we are not bumping into a little hard ball. We are hitting a force field that emanates from a dimensionless center. The closer you get to that center, the stronger the force becomes, scaling up towards infinity, guarding the singularity within. We can never touch the point itself. We can only interact with the sphere of influence that radiates from it. This definition of the electron as a point is not just a lazy approximation. It is the rigid stance of the standard model. Experiments have probed the electron's size down to scales of 10, -18 meters, a billionth of a meter, and found no evidence of surface, no evidence of structure, no evidence of spatial extent. At every scale we have ever measured, it remains a point. It is stubbornly, defiantly zero. This reality creates a deep cognitive dissonance. We are creatures of biology, built of cells, which are built of molecules, which are built of atoms. We live in a world of extension and volume. It is disturbing to realize that the foundation of this volume is built from bricks that have no volume. It implies that size is an emergent property, something that arises from the interaction of things that have no size. It suggests that the universe, at its most fundamental resolution, is not made of stuff in the way we understand it, but rather of information packets of mass, charge, and spin assigned to coordinate points in a void. Furthermore, the spin of this point particle adds another layer to the mystery. In our world, a spinning top has angular momentum because its mass is rotating around a center. But if the electron is a point, it cannot rotate. A point looks the same from every angle. Yet, we measure its angular momentum. It generates a magnetic field exactly as if it were a tiny, spinning sphere of charge. Physics calls this intrinsic angular momentum. It means the electron doesn't spin physically. It simply is spin. Spin is not something the electron does. It is what the electron is. The property is stamped onto the point as indelibly as its mass. It is a quantum label, a value inherent to the particle's existence, divorced from the mechanical motion we see in tires or tops. The search for the electron's boundary is, therefore, a journey into a hall of mirrors. We chase a physical edge, a rim, a surface, but we find only the intensifying scream of an electric field. We look for the body of the particle, and we find only a list of properties. We are forced to conclude that the building blocks of reality are not like the building blocks of a house. A brick has a shape independent of its function, An electron is nothing but function. It is a set of rules localized at a point. As we stare into this dimensionless point, we are staring at the limit of human intuition. We are confronting the possibility that matter is a dated concept, a macroscopic misunderstanding of a universe that is actually composed of mathematical relationships. The electron is the ultimate gatekeeper of this secret. It sits at the bottom of the rabbit hole, smaller than small, occupying no space, yet holding the universe together with its electric grip. It is the dimensionless ghost that gives the world its weight, the zero that adds up to everything. We want it to be a ball, but it refuses. It remains a piercing, singular point, defying our desire for solid ground, floating in the abyss of the subatomic, mocking our geometry with its perfect, terrifying lack of dimensions. In the realm of science, mathematics is the language of truth. It is the bedrock upon which we build bridges, navigate spacecraft, and predict the motion of the planets. We trust equations because they are precise, logical, and unforgiving. They do not lie. However, when we take the accepted laws of physics and apply them to the model of the electron as a dimensionless point, something catastrophic happens to that language. The equations do not just struggle, they scream. They return values that are not merely large or complex, but impossible. We arrive at a mathematical breakdown, a singularity where the logic of the universe appears to snap in half. This is the paradox of infinite density, the nightmare that haunts the foundation of modern physics. To understand the severity of this problem, we must return to the simple definition of density. In our everyday lives, density is a measure of how much stuff is packed into a specific amount of space. A lead ball is denser than a foam ball because it packs more mass into the same volume. The formula is beautifully simple. You take the mass of an object and divide it by its volume. If you keep the mass the same but shrink the volume, the density skyrockets. If you squeeze the Earth into the size of a basketball, it becomes incredibly dense. If you squeeze it into the size of a marble, it becomes a black hole. But in both cases, there is still a volume, there is still a size to divide by. Now, consider the electron. As we established, the standard model defines it as having a fixed mass, a very small but definite number. But it also defines the electron as having zero radius, and therefore zero volume. When we attempt to calculate the density of an electron, we must take its mass and divide it by zero. In the strict laws of mathematics, division by zero is an illegal operation. It is undefined. It yields a result of infinity. This means that according to our current best theories, the electron is not just dense, it is infinitely dense. It implies that at every single point where an electron exists in the atoms of your eyes, in the screen you are reading, in the air you breathe, there are tiny pinpricks of infinite density. This is physically absurd. In the real world, infinity is not a measurement. It is a concept, an abstraction. We do not find objects of infinite height, nor do we find batteries with infinite voltage. To find infinite density inside a stable, common particle like the electron suggests that our mathematical map of reality has driven off a cliff. The problem deepens when we look at the electric field. Every electron is surrounded by an electromagnetic field that pushes other electrons away. The strength of this force is determined by the inverse square law. This law states that as you get closer to the source of the charge, the force increases. If you halve the distance, the force quadruples. If you cut the distance to a tenth, the force increases by a factor of 100. This works perfectly fine in the macroscopic world, because you can only get so close to the center of a charged ball before you hit its surface. The surface acts as a barrier, preventing you from getting any closer to the center of the charge. But the electron has no surface. It has no barrier. Because it is a point particle, you can, in theory, get closer and closer to the center forever without ever hitting a wall. As the distance approaches zero, the force required to be there approaches infinity. If you were to plot the strength of the electron's electric field on a graph, it would not act like a hill. It would look like a spike rising vertically, shooting up off the page, piercing the ceiling, and going up forever. This is what physicists call a singularity. It is a point in space where the curvature of the field becomes so extreme that the laws of physics essentially throw up their hands and quit. This infinite field leads to an even darker problem known as the self-energy crisis. Energy and mass are interchangeable, as Einstein famously proved. An electric field contains energy. Because the electron's field gets stronger and stronger as you get closer to the core, the total energy contained within that field becomes massive. In fact, if you calculate the energy of the field surrounding a point-sized electron, the result is, once again, infinity. Since energy is mass, an electron with infinite energy should have infinite mass. If this were true, a single electron would be heavier than the entire universe. It would instantly collapse into a black hole, sucking the entire atom, the entire Earth, and the entire solar system into it. Obviously, this does not happen. We know the electron is light. It is one of the lightest particles in existence. It dances nimbly around the nucleus. So, we are left with a glaring contradiction. Our math says the electron should be a monster of infinite mass, but reality tells us it is a featherweight. The theory predicts a catastrophe, but the universe remains stable. For decades, this infinity problem threatened to destroy quantum physics. It suggested that the theory of the point particle was fundamentally broken. How could the most successful theory in history be based on a premise that yields such nonsensical results? Physicists in the mid-20th century had to invent a mathematical workaround called renormalization to deal with this nightmare. In simple terms, they essentially looked at the equation that said infinity and subtracted another infinity from it to get the small, finite number that matches the measured mass of the electron. They balanced the books by manually removing the impossible parts. While this mathematical trick works, it allows us to make predictions with staggering accuracy. It has always felt like a sleight of hand. It is like sweeping the dust under the rug. The infinities are still there, lurking in the mathematics, hidden but not resolved. Richard Feynman, one of the fathers of this technique, called it a dippy process, admitting that he suspected they were not solving the problem but merely painting over it. This breakdown points to a profound truth. Our understanding of the core of the electron is incomplete. The appearance of infinity in a physical equation is almost always nature's way of telling us that we have zoomed in too far or that we are using the wrong rules for the environment. It suggests that down at the scale of the electron, the concepts of space and distance might cease to mean what we think they mean. Perhaps the assumption that the electron is a point is the flaw. If the electron had a size, even a size as small as the Planck length, the math would settle down. The division by zero would disappear. The energy would be finite. But as we have seen, every experiment tells us it is a point. So, we are stuck in a trap. If we give it size, we contradict experiment. If we call it a point, we break mathematics. This paradox is the friction point between the two great pillars of physics, general relativity and quantum mechanics. General relativity, which governs gravity and the shape of space-time, cannot handle points. It requires smooth, continuous fabrics. A point of infinite density punctures that fabric, creating a singularity that breaks the equations of gravity. Quantum mechanics, on the other hand, embraces the point particle but has to cheat the math to make the energy calculations work. They are like two different operating systems that cannot talk to each other, and the electron is the file that crashes both of them. The horror of the infinite density paradox is not just a calculation error, it is a sign that the universe has a resolution limit. Just as a digital image is made of pixels, and you cannot zoom in past the single pixel without the image becoming a meaningless block of color, the universe may have a pixel size. The point particle model tries to zoom in past that pixel, treating reality as infinitely smooth, and the result is mathematical noise. We are forced to consider that the electron acts like a point not because it is a point, but because the structure that composes it exists in dimensions we cannot perceive, or operates on a geometry that our Euclidean minds cannot visualize. The infinite density is a warning sign. It tells us that we have reached the edge of the map. We are standing on the precipice of the unknown, holding a calculator that displays error, looking at a particle that weighs almost nothing, yet holds the mathematical weight of a black hole at its center. This breakdown is the fertile ground from which new theories must grow. It drives physicists to look for strings, for loops, for granules of space-time, anything that can cure the plague of infinities. But for now, in the standard view, the electron remains a paradox wrapped in a mystery. It is a ghost that haunts our equations, a zero that threatens to become an infinity, a reminder that for all our knowledge, the heart of matter is still a place where our logic goes to die. We have dismantled the atom, we have peered into the void, but when we try to touch the core, the math dissolves, leaving us floating in a sea of impossible numbers. The electron is not just a particle. It is a glitch in the matrix of our understanding, a silent sentinel guarding the deeper, truer laws of reality that we have yet to discover. If the universe operated solely on the laws of classical attraction, we would not be here to discuss it. In fact, nothing would be here. The very existence of matter is a defiance of the simplest rule we know: opposites attract. We have established that the atom consists of a positively charged nucleus and negatively charged electrons. According to the logic of electromagnetism, the same logic that snaps two magnets together, the electron should be irresistibly pulled toward the nucleus. It should spiral inward, radiating away its energy as it falls, crashing into the proton in a fraction of a second. This catastrophic collapse would happen to every atom in the cosmos simultaneously. The universe should have ended moments after it began, imploding into a dense, neutral soup of matter with no structure, no chemistry, and no light. The fact that you are sitting here, breathing and reading, is proof that there is a force at play that is stronger than attraction, a hidden law that holds the atomic roof up and prevents the sky from falling. These invisible protectors are the quantum sentinels. To understand why the atom does not collapse, we must abandon the idea of the electron as a passive object and view it instead as a creature of frantic, unstoppable motion. This behavior is governed by the first of our sentinels, the Heisenberg uncertainty principle. Often misunderstood as a mere limitation of measurement, as if our rulers aren't good enough, this principle is actually a fundamental property of nature. It states that there is a strict limit to how much we can know about a particle's properties at the same time. Specifically, We cannot know both the position and the momentum of an electron with perfect precision. It is a cosmic trade-off. The more precisely you pin down where a particle is, the less you know about where it is going or how fast it is moving. This seems like a philosophical quirk, but inside the atom, it becomes a structural pillar. Imagine the electron as it gets pulled closer and closer to the nucleus. As the electron is squeezed into that tiny space near the protons, its position becomes more and more defined. We know where it is. It is near the center. But nature forbids this absolute certainty. To satisfy the uncertainty principle, as the location becomes precise, the momentum must become wild and uncertain. The electron begins to vibrate with frantic energy. It develops a claustrophobia of the highest order. The tighter the electrical noose pulls it in, the faster and more erratically it moves to maintain its quantum fuzziness. This creates a kind of quantum pressure. It is not a force in the traditional sense, like gravity or magnetism. It is a kinetic refusal to be confined. The electron refuses to crash into the nucleus, because doing so would require it to have a definite position at the nucleus and a definite velocity, stopped, which violates the fundamental laws of existence. The electron survives by remaining a blur. It enters a state of hypermovement, buzzing around the nucleus like a trapped insect moving so fast it becomes a cloud. This zero-point energy means the electron can never rest, it can never stop. It is held in a permanent, trembling balance between the electric force pulling it in and the quantum uncertainty pushing it out. This is the first reason the universe is voluminous. Matter takes up space because its components are frantically pacing back and forth to avoid being pinned down. However, the uncertainty principle alone is not enough to explain the complexity of the world. If that were the only rule, all the electrons in an atom would simply pile up in the lowest possible energy state, huddled as close to the nucleus as the uncertainty principle allows. They would all occupy the same cloud, overlapping and merging. If this happened, every atom would behave like hydrogen. We would have no chemistry. We would have no complex bonds. We would have no life. The universe would be a monotonous gas of identical spheres. Enter the second sentinel, the architect of diversity, the Pauli exclusion principle. Discovered by Wolfgang Pauli, this law is the reason solid objects feel solid. It is the reason you cannot walk through a wall. The principle is deceptively simple. No two fermions, the class of particles that includes electrons, can occupy the exact same quantum state in the same system at the same time. You can think of the atom not as a chaotic swarm, but as a highly regulated parking structure or an exclusive amphitheater with assigned seating. Every electron in an atom must have a unique ID card. This ID is defined by 4 quantum numbers: its energy level, its shape, its orientation, and its spin. The most critical of these is spin. An electron can spin up or down. This means that in any given orbital which you can imagine as a specific parking spot in the electron cloud, you can fit exactly 2 electrons, one spinning up, one spinning down. Once those 2 spots are taken, that orbital is full, it is closed, it is locked. If a third electron tries to enter that state, the Pauli exclusion principle acts as an impenetrable barrier. It says, no vacancy. That third electron is forced to move to a higher energy level, a different orbital that is further away from the nucleus. This is why atoms have layers. As you add more electrons to an atom, creating carbon, oxygen, iron, gold, they cannot just sink to the bottom. They must stack on top of each other, filling shell after shell, expanding the size of the atom as they go. This stacking mechanism is what gives elements their unique chemical personalities. It is the arrangement of the outermost electrons, the ones forced to the edge by the exclusion principle, that determines how an atom bonds with others. This refusal to share space is the source of the rigidity of matter. When you press your hand against a table, you are witnessing a clash of quantum sovereignties. The electrons in the atoms of your hand are in their specific energy states. The electrons in the atoms of the table are in theirs. As you push closer, the electron clouds begin to overlap. The Pauli exclusion principle screams in protest. The electrons in the table cannot move into the states occupied by your hand's electrons because those slots are already taken. To avoid occupying the same state, the electrons would have to jump to much higher energy levels, which requires a massive amount of energy that your push does not provide. The result is a fierce, repulsive force. It is not just electric repulsion, it is a degeneracy pressure, a fundamental resistance to overlapping identities. You are feeling the force of the electrons fighting for their right to be unique. This is why matter creates volume. It is not because the particles are big, remember. They are dimensionless points, but because the laws governing them carve out exclusive territories. The Pauli exclusion principle essentially inflates the atom, turning a collection of point particles into a structural brick. Together, these two sentinels, Heisenberg and Pauli, perform a miraculous juggling act. Heisenberg keeps the electron from collapsing into the nucleus, forcing it to dance a frantic jitterbug that puffs it out into a cloud of probability. Pauli prevents the electrons from collapsing into each other, forcing them to arrange themselves in intricate, geometric shells. They turn a chaotic attraction into a stable architecture. They transform the emptiness into a barrier. Consider the implications of this constant motion. The solidity of a diamond is an illusion created by speed and exclusion. It is comparable to the blade of a fan. When the fan is off, you can put your hand between the blades. There is mostly empty space, but when the fan spins at high speed, that empty space becomes a solid disk that you cannot penetrate. The electrons are spinning at speeds that defy comprehension, weaving a fabric out of their trajectories. We are walking on a floor made of time and motion, supported not by static beams, but by the sheer velocity of the subatomic world. This quantum dance is also the reason the universe is not dark, because electrons are forced into these discrete energy shells. When they jump between them, they absorb and release light. If they were allowed to crash into the nucleus, they would emit a continuous, dull hum of radiation and then fall silent. Instead, because they must jump from one specific rung of the ladder to another, they emit photons of specific colors. The color of a rose, the blue of the sky, the glow of a neon sign, all of these are the result of electrons navigating the strict traffic rules enforced by the quantum sentinels. There is something almost poetic in the violence of this stability. Peace, at the atomic level, is not a stillness. It is a stalemate between opposing catastrophes. The atom is stable only because the electron is trapped in a permanent state of panic, trying to be everywhere at once to satisfy Heisenberg, while simultaneously navigating the rigid bureaucracy of Pauli's exclusion zones. We exist in the eye of this quantum storm. The calmness of a glass of water or the stillness of a stone is a macroscopic lie covering up a microscopic frenzy. These principles are the guardians of complexity. Without the exclusion principle, the universe would be a boring soup of Boson's particles that like to clump together. There would be no stars, for stars rely on this same pressure to resist their own gravity. There would be no chemistry, for chemistry is the game of trading electrons between outer shells. There would be no biology, for DNA relies on the specific shapes and bonds that only these exclusions can create. So, when we ask, why doesn't the universe collapse? The answer is not found in the strength of materials, but in the laws of information and probability. The universe stands tall because its fundamental particles are stubborn. They refuse to be pinned down to a single location, and they refuse to surrender their individuality. We are built from ghosts that demand their own space. It is this defiant independence of the electron, this absolute refusal to conform or compress, that gives the universe its breadth, its beauty, and its ability to hold us. The emptiness we spoke of earlier is not merely empty, it is fiercely guarded territory, patrolled by the frantic motion of the quantum sentinels, ensuring that the void remains open, structured, and capable of life. We have reached a pivotal moment in our descent into the heart of matter. Thus far, we have deconstructed the electron from a solid sphere to a dimensionless point, a mathematical ghost haunting the atomic shell. Yet, even the concept of a point particle carries a lingering bias of our macroscopic minds. We still imagine a dot that exists separate from the space it occupies, like a lonely actor standing on an empty stage. To truly understand the nature of the electron, and by extension the nature of our reality, we must dissolve the actor and the stage into one. We must abandon the intuitive world of things and enter the counterintuitive, shimmering reality of quantum field theory. In this realm, particles do not exist as independent entities. They are merely transient moments in a far grander, invisible structure. Imagine for a moment that the universe is not a vacuum filled with scattered debris, but a vast, silent ocean. This ocean is fluid, dynamic, and stretches to the infinite edges of the cosmos. It fills every millimeter of space in your room. It permeates the dense core of the Earth, and it spans the cold voids between galaxies. This ocean is not made of water. It is made of potential. Physicists call this the electron field. And here is the revelation that changes everything. The electron is not a boat floating on this ocean. The electron is not a drop of oil sitting in this water. The electron is a wave of the ocean. When we speak of an electron, we are not speaking of a permanent individual object. We are speaking of a localized disturbance, a ripple, a spike in the energy level of this all-encompassing field. Just as a wave cannot exist without the water, the electron cannot exist without the field. It is a knot of energy, a tightly wound vibration that travels through the fabric of the universe. When you move your hand, you are not moving a collection of tiny balls. You are moving a complex cluster of ripples through a stationary field. The matter moves, but the medium stays. It is like a sound wave moving through the air. The sound travels across the room, but the air molecules themselves mostly vibrate in place. We are, in essence, patterns of information propagating through a timeless medium. This shift from particle to field solves one of the greatest mysteries of physics. Why is every electron identical? If electrons were factory-made objects, like cars or coins, you would expect minor variations. One might be slightly heavier, another might have a slightly stronger charge, another might be scratched or dented. But in the history of science, every single electron ever observed has been exactly the same. They are indistinguishable. You could take an electron from a hydrogen atom in your tear duct and swap it with an electron from a star on the edge of the observable universe, and the universe would not notice the difference. Quantum field theory explains this perfection effortlessly. There are not trillions of separate electrons. There is only one electron field. Every electron that exists is simply an excitation of this singular entity. They are all identical because they are all made of the exact same stuff, the fundamental vibration of the field itself. Just as every middle C played on a perfectly tuned piano rings with the exact same frequency, every electron is a harmonic note played on the instrument of the electron field. The universe is not a collection of Lego bricks. It is a symphony, and matter is the music. This perspective fundamentally alters our quest to find what is inside the electron. When we imagined the electron as a ball, it made sense to ask what was inside it. But if the electron is a knot in a field, the question becomes meaningless. Ask yourself, what is inside a whirlpool? If you look closely at a whirlpool in a river, you see water. If you look inside the whirlpool, you just find more water moving faster. There is no hard kernel at the center of the vortex. The whirlpool is a structure, not a substance. It is a behavior of the river. Similarly, if we could zoom into the electron knot, we would not find a smaller gear or a hidden battery. We would simply find the field itself, vibrating with intense energy. The inside is the same as the outside. The electron is a concentration of the field, a place where the values of the field spike above zero. There is no boundary where the electron ends and the empty space begins, because the empty space is just the field at rest. The electron is the field awake. This realization leads us to a startling conclusion about the nature of empty space. In the classical view, a vacuum is a void, a place where nothing exists. In quantum field theory, a true vacuum is impossible. Even if you remove all the atoms, all the light, and all the radiation from a box, the fields remain. The electron field is still there. The electromagnetic field is still there. The Higgs field is there. They are merely in their lowest energy state, sitting quietly like the surface of a calm lake. But thanks to the jittery laws of quantum mechanics, this lake is never perfectly still. It boils, it froths. The vacuum is a chaotic soup of virtual particles. These are ripples that rise up out of the field and dissolve back into it almost instantly. Pairs of electrons and their antimatter twins, positrons, are constantly snapping into existence and annihilating each other in the void, borrowing energy from the vacuum and paying it back within fractions of a nanosecond. This means that the nothingness inside your atoms and in the space around you is actually a torrential storm of activity. The knot that is the real electron is simply a stable, long-lasting wave riding on top of this quantum foam. It is a permanent storm amid the flickering ones. Understanding the electron as a knot in a field also demystifies how particles are created and destroyed. In particle accelerators, we smash electrons and positrons together, and they vanish, releasing a burst of gamma rays. In the particle model, this is like magic matter turning into energy, but in the field model, it is intuitive. Imagine a wave on a rope traveling left and a trough traveling right. When they meet, they cancel each other out. The rope goes flat. The energy of the motion doesn't disappear. It is transferred to a different medium or released as a vibration in a connected field, the photon field. The electron and the positron are just opposite twists in the same fabric. When they collide, they untie the knot. The tension is released, the ripples flatten out, and the energy flows away as light. Matter is not destroyed. The disturbance merely calms down. This view implies that solidity is a property of the field's topology. We feel solid because these knots are stable. They are self-reinforcing. Unlike the fleeting virtual particles, the electron knot is tied in a way that prevents it from simply unraveling on its own. It carries a conserved quantity electric charge, which acts like a lock. The field cannot just go flat. The charge must go somewhere. This stability allows the knots to stack, to bond, and to build the complex structures of atoms. But ultimately, we are woven from the same immaterial cloth as the light passing through a window or the magnetic force sticking a drawing to a fridge. We are coherent lumps of energy in a universal web. The distinction between the material and the immaterial dissolves here. In our daily lives, we treat matter, rocks, tables, flesh, as real, and fields, gravity, magnetism, as invisible ghosts that act upon the real stuff. Quantum field theory inverts this. The fields are the real stuff. They are the primary reality. The matter is just a secondary phenomenon, a transient symptom of the field's activity. The ground you walk on is an excitation of a field. The air you breathe is a vibration. Your brain, contemplating these words, is a complex, dancing pattern of knots interacting with other knots, exchanging force, carrying ripples across the silence. So, when we ask what is hidden inside an electron, the answer is the universe. Literally, the field that constitutes the electron extends everywhere. To touch an electron is to touch a thread that is woven into the furthest stars. There is no localized core because the electron is an expression of a non-localized reality. It is a pinch in the cosmic sheet. This is a terrifying and beautiful thought. It suggests that we are continuous with the cosmos. We are not inhabitants of the universe. We are the universe behaving in a specific way. The separation between me and you, between the particle and the void, is a macroscopic illusion. At the foundational level, there are no boundaries. There is only the field, shifting, undulating, tying itself into knots that we call matter and untying them into bursts that we call light. The core of the electron is not a thing. It is a doorway into this underlying unity. It is the hum of the vacuum. It is the mathematical breath of the cosmos. As we look at the electron now, we no longer see a tiny, hard point. We see a luminous, pulsating focal point of a web that has no beginning and no end. We see a dynamic architecture where empty space is the building material, and matter is the architectural form. The mystery of the point is resolved not by finding its dimensions, but by realizing that the point is just the coordinate where the ocean rises. And if we could dive into that knot, we would not hit a wall. We would fall through the rabbit hole into the deeper, vibrating 11-dimensional structures that might explain why the field vibrates at all. The journey into the knot is just beginning. We have peeled back the layers of reality, moving from the illusion of solid objects to the empty cathedral of the atom, descending into the frantic motion of the quantum cloud, and finally dissolving the particle into a ripple in a universal field. Yet, even as we float in the ocean of quantum field theory, a nagging problem remains. The mathematics of the point particle, the concept of a zero-dimensional singularity, still lurks at the center of our understanding, threatening to break the laws of gravity. To resolve the final paradoxes of the electron, we must take one last, desperate zoom into the unknown. We must go smaller than we have ever dared to imagine, plunging down to the Planck scale, a realm 100 billion times smaller than the nucleus of an atom. Here, the ripples of the field reveal their true structure. If we could see with the clarity of a god, we would discover that the electron is not a point, nor is it merely a wave. It is a tiny, vibrating loop of energy. We have arrived at the domain of string theory. In this new vision of the cosmos, the fundamental constituent of reality is a one-dimensional filament, a string. This string is the ultimate indivisible unit. It is not made of atoms. Atoms are made of it. It is not made of quarks. Quarks are made of it. It is the raw material of existence itself. This tiny strand of energy resolves the nightmare of the point particle by finally giving the electron a size. It is incredibly small, so small that if an atom were the size of the solar system, a string would be the size of a tree on Earth. But it is not zero. It has length. This simple fact saves physics. Because the electron is a loop rather than a point, its interactions are smeared out over space. There are no singularities, no infinite densities, no mathematical explosions. The string softens the violence of the subatomic world, allowing the laws of gravity and quantum mechanics to finally shake hands without the universe falling apart. But the true beauty of string theory lies not in its size, but in its behavior. To understand what an electron is in this model, we must think of a musical instrument. Consider a guitar string. Depending on how you pluck it, how tight it is, and where you place your finger, that single string can produce a middle C, a high E, or a G sharp. The string itself remains the same material, but the vibration changes the note. String theory proposes that the universe operates on this exact same principle. The electron is not a fundamental object distinct from a quark or a neutrino. Rather, they are all the same object, the fundamental string vibrating at different frequencies. The electron is simply a string oscillating with a specific pattern or note. If you could somehow grab an electron string and pluck it differently, adding more energy to its vibration, it would cease to be an electron. It might transform into a muon, or a top quark, or a photon. The properties that we think of as rigid constants, mass, charge, and spin, are actually determined by the geometry of the vibration. Mass is simply the energy of the song. A heavy particle is a string vibrating frantically, a high-pitched scream of energy. An electron, which is very light, is a string humming a low, gentle tune. This realization transforms our understanding of the core of the electron. There is no hard kernel inside. There is no hidden machinery. The inside of an electron is music. It is a resonant frequency of the fabric of space-time. The universe, therefore, is not a collection of separate Lego bricks. It is a cosmic symphony. The vast diversity of matter in the universe, from the carbon in your skin to the hydrogen in the sun, is essentially a variation on a theme, played on 1 trillion tiny violins. However, for this symphony to exist, the orchestra needs room to play. And this brings us to the most mind-bending aspect of the theory, the stage upon which these strings vibrate. In our everyday experience, we live in a world of 3 dimensions, of space, height, width, depth, and 1 dimension of time. We move left and right, forward and backward, up and down. But the mathematics of string theory refuses to work in this limited space. When physicists attempt to calculate the vibration of an electron string in a 3D universe, the equations collapse. They produce negative probabilities and physical impossibilities. For the strings to vibrate with the complexity required to create the electrons and forces we see, they need more freedom. They need more directions to wiggle in. The math demands a specific number, 11. According to M theory, the leading version of string theory, we do not live in a 4-dimensional universe. We live in an 11-dimensional multiverse. There are the 3 spatial dimensions we see, 1 dimension of time, and 7 extra spatial dimensions that are hidden from our senses. Where are these extra dimensions? Why can't we see them? The answer lies in their size and shape. Imagine looking at a garden hose lying on the grass from 100 yards away. To your eyes, the hose looks like a 1-dimensional line. You can only run your finger along its length. But if you walk up to the hose and look closely, you realize it has a 2nd dimension, the circumference. An ant crawling on the hose can move along the length, but it can also loop around the circle. The circular dimension was always there, but it was curled up so tightly that it was invisible from a distance. String theory suggests that every point in our familiar 3D space is actually like that garden hose, but far more complex. At every point in the empty air in front of your face, there are 7 extra dimensions curled up into incredibly tiny, complex shapes called Calabi-Yau manifolds. These shapes are not just circles. They are twisted, folded, multi-dimensional origami knots of space-time. They are everywhere, woven into the fabric of the vacuum, but they are smaller than the string itself, so we never perceive them. This is where the secret of the electron truly lies. The electron string is not just vibrating in the 3 dimensions we can see. It is threading itself through these hidden, curled-up dimensions. It is wrapping around the loops and folds of the Calabi-Yau shapes like a snake slithering through a complex tunnel system. The shape of these hidden dimensions determines the vibration of the string, just as the shape of a French horn determines the sound of the air blown through it. The geometry of these extra dimensions dictates the sound of the string. This explains why the electron has the specific mass and charge that it does. The electron is the way it is because the string is vibrating against the walls of these invisible 7-dimensional shapes. If the Calabi-Yau shapes were folded differently, the string would vibrate differently, the note would change, and the electron might be heavier or have no charge at all. In that case, chemistry would be impossible, and the universe, as we know it, would not exist. We are the result of the specific geometry of hidden hyperspace. The core of the electron, then, is a geometric relationship between a strand of energy and the hidden architecture of the universe. This perspective offers a profound unification. For a century, physics has been divided. We had one set of rules for the big things, gravity, and another for the small things, quantum mechanics. They refused to speak to each other. But string theory offers a peace treaty. Among the many vibrational patterns a string can adopt, there is one specific mode, a closed loop spinning in a certain way that corresponds perfectly to the properties of the graviton, the theoretical particle that carries the force of gravity. This means that gravity is not an enemy of the electron. It is just another song played on the same instrument. The electron is an open string or a loop attached to our membrane of reality, and gravity is a closed loop floating freely. They are siblings. For the first time, we have a framework that can describe the falling of an apple and the orbit of an electron using the exact same physical model. The core of the electron is made of the same stuff as the force that holds the galaxies together. So, what is truly hidden inside an electron? If you could peel back the field, Look past the point and peer into the 11-dimensional heart of the particle. You would see a tiny filament of energy dancing. It is a dance that weaves through dimensions we cannot see, tracing out the curves of a geometry we can barely comprehend. It is a loop of tension, humming with the anxiety of existence, frantically vibrating to maintain its identity as a piece of matter. There is no substance here, only form and frequency. The solid world is a trick of resonance. We are made of vibrating strands, singing in the dark void. The solidity of your body is just the harmony of trillions of strings playing in unison. The electron is a song that has been playing since the Big Bang, a standing wave on the strings of the cosmos. And perhaps the most humbling realization is that the string itself is likely made of nothing but pure geometry, a ripple in the texture of space-time itself. The search for the thing at the bottom of the well ends with the realization that there are no things, there is only the vibration. The universe is a vast, silent instrument, and the electron is one of its fundamental chords. We are not the conductors of this symphony, we are the music. And as the string vibrates, it echoes through 11 dimensions, binding the visible world to the invisible, the momentary to the eternal, and the particle to the infinite. The core of the electron is the heartbeat of a living, breathing, multidimensional reality. The journey into the heart of matter has taken us from the illusion of touch to the emptiness of the atom, through the vibrating strings of hyperspace and the shimmering knots of the quantum field. We have deconstructed the what and the where of the electron, but now we must confront the most unsettling question of all, the who. When we look at the universe, we see a cosmos teeming with an incomprehensible number of electrons. There are electrons in the clouds drifting overhead, electrons in the magma beneath our feet, electrons firing in the synapses of your brain, and electrons burning in the nuclear furnaces of stars billions of light years away. The estimated number of these particles in the observable universe is 10, followed by 80 zeros. It is a number so vast that it renders the human imagination impotent. And yet, amidst this infinite swarm, there is a peculiar, haunting fact that has kept physicists awake at night for a century. Every single one of them is exactly the same. In the biological world, distinctiveness is the rule. No two fingerprints are alike. No two snowflakes are identical. Even identical twins have subtle variations. But in the subatomic world, uniformity is absolute. If you take an electron from the tip of your finger and compare it to an electron harvested from a quasar on the edge of time, they are indistinguishable. They have the exact same mass. To the last decimal point, they have the exact same charge. They have the exact same spin. There is no old electron or new electron, no damaged electron or special electron. They are perfect clones. Standard physics accepts this as a fundamental law, but in the spring of 1940, the brilliant physicist John Archibald Wheeler called his student, Richard Feynman, with a radical proposition that offered a different explanation. He didn't suggest that there are trillions of identical electrons. He suggested that there is only one. This hypothesis, known as the One-Electron Universe, is perhaps the most mind-bending thought experiment in the history of science. It proposes that the reason all electrons look and act exactly alike is that they are all the same particle. The illusion of the many is created by the way this single traveler moves through the dimension of time. To understand this, we must visualize the universe not as a series of snapshots, but as a continuous block of space-time, a loaf of reality where the past, present, and future exist simultaneously. In this view, a particle traces a path called a world line. A normal object, like a rock or a person, has a world line that moves steadily from the past into the future. It is a straight line. But Wheeler asked us to imagine a particle that is not bound by the flow of time. Imagine a particle that can weave through the fabric of history like a needle stitching a tapestry. According to this theory, the single traveler begins its journey at the dawn of time, at the Big Bang. It travels forward through billions of years, creating a track that we might identify as an electron in a hydrogen atom. It travels all the way to the end of the universe, to the final entropic heat death. But instead of dying, the particle hits the barrier of the end of time and bounces off. It executes a cosmic U-turn. It begins to travel backward in time, from the future toward the past. Here is the stroke of genius that anchors this wild idea in real physics. Mathematically, an electron moving backward in time is indistinguishable from an antimatter particle moving forward in time. Antimatter is the mirror image of matter. The antimatter twin of the electron is the positron, a particle with the same mass but a positive charge. When Wheeler looked at the equations, he realized that the reversal of time flips the charge. So, as our single traveler races back from the end of the universe toward the Big Bang, we perceive it not as an electron moving backward, but as a positron moving forward. The single traveler reaches the beginning of time, hits the energy of the Big Bang, and bounces again, heading back toward the future. It becomes an electron once more. It travels forward, lives through history, reaches the end, turns around, and becomes a positron again. It repeats this zigzag journey billions upon billions of times. It is like a single long thread passed back and forth through a piece of fabric. If you slice the fabric down the middle and look at the cross-section, you will see millions of tiny red dots and blue dots. You might think they are millions of separate individual particles, but if you could look at the whole cloth, you would see that it is just one incredibly long, tangled thread. The electrons are the thread moving forward. The positrons are the thread moving backward. This theory transforms the universe from a crowded room into a hall of mirrors. It implies that the electron in the iron of your blood is the same electron that is currently powering the storm on Jupiter. It is the same electron that existed in the dinosaur's eye. It is the same electron that will constitute the cold dust of a dead galaxy trillions of years from now. It means that every interaction in the cosmos is essentially the particle interacting with itself at a different point in its own timeline. The universe is a monologue disguised as a dialogue. The implications of the One-Electron Universe are profoundly intimate. It dissolves the boundaries of separation that define our existence. We tend to think of ourselves as isolated entities, I versus the world. But if this hypothesis holds even a grain of metaphorical truth, then the substance of your body is woven from the same single thread that weaves the body of your loved ones, your enemies, and the stars above you. We are not just made of star stuff. We are made of the same piece of star stuff, endlessly folded over on itself. The complexity of the universe, the galaxies, the planets, the life forms is merely the result of the complexity of the knot. The more the single traveler zigzags, the more matter appears to exist at any given moment. This model also offers a beautiful, albeit strange, explanation for the phenomenon of matter-antimatter annihilation. In standard physics, when an electron meets a positron, they destroy each other and turn into pure energy, photons. It is a violent death. But in the Wheeler-Feynman view, this event is not a death at all. It is a corner. It is simply the moment where the particle decides to turn around in time. What looks to us like an explosion is actually the single traveler hitting a wall in the time stream and reversing its direction. The electron, moving forward, meets the positron itself, moving backward. They link up, and the continuous line curves away. Nothing is destroyed. The path simply continues in a different direction. Of course, the theory has its critics and its paradoxes. The most glaring issue is the missing antimatter. If the particle goes back and forth an equal number of times, there should be exactly as many positrons in the universe as there are electrons. We should see a universe balanced between matter and antimatter. Instead, we see a universe dominated by matter. Where are all the backward traveling sections of the thread? Wheeler, in his characteristic whimsy, suggested they might be hiding inside protons or neutrons, or perhaps the immense knot is tangled in such a way that we are currently living in a forward-heavy section of the tapestry. Or perhaps the positrons are the dark matter, or the vast voids between galaxies. The discrepancy remains a mystery, but it does not diminish the haunting elegance of the idea. There is a deep, existential loneliness to the single traveler. It suggests that at the fundamental level, the universe is a solitary endeavor. There is only one. It is rushing through the void, creating the illusion of a crowd through its sheer speed and persistence. It is a cosmic dancer moving so fast that it appears to be a corps de ballet. This perspective shifts our understanding of time itself. Time is no longer just a river carrying us away. It is the canvas upon which the electron paints reality. The particle uses time as a tool, reusing the same moments over and over again to build up the density of existence. Consider the electron currently resting in the atom of the screen you are looking at. In the one-electron model, that particle has already seen the end of the universe. It has already been a positron in the ancient plasma of the first moments of creation. It carries within it the history of infinite journeys. It is older than time itself because it has traversed the length of time nearly infinite times. It is an ancient, weary traveler wearing the mask of a fresh, young particle. This theory serves as a bridge between physics and philosophy. It forces us to confront the idea that multiplicity might be an illusion of perspective. Just as a prism splits white light into a rainbow of colors, the dimension of time splits a single entity into a universe of particles. The separation we see, the distance between the Earth and the Moon, the gap between two hands, is just the space between two loops of the same string. The vacuum is not empty, it is the loom. Whether the one-electron universe is literally true or merely a mathematical curiosity, it teaches us a vital lesson about the core we are searching for. We have been looking for a what, a hard kernel, a definitive object, but the answer might be a process. The electron is not a dot, it is a trajectory. It is a relationship between a point and the entirety of space-time. The inside of the electron is a tunnel that leads everywhere and everywhen. As we hold this thought, the solidity of the world softens. The frantic motion of the quantum sentinels, the vibration of the strings, the ripples in the field, they all converge into this singular narrative. The universe is a single, unbroken line, frantic to experience itself, knitting itself into knots of such complexity that the knots begin to wake up, look around, and ask, "What am I?" We are the knot asking the string about its nature. We are the traveler, wondering why there are so many of us, unaware that we are looking in a mirror that shatters time. The electron is the ultimate Ouroboros, the snake eating its own tail, forever consuming and creating itself in the grand, lonely architecture of the cosmos. To look at a human hand is to witness a quiet miracle of stabilization. We see skin, veins, and muscle. We perceive warmth and texture. We feel a unified, coherent object that obeys our will. But having journeyed through the quantum landscape, we now possess a second sight, a terrifying and beautiful transparency that reveals the true nature of this flesh. We know that what appears to be a solid limb is, in reality, a frantic swarm of probability clouds, a localized storm of dimensionless points vibrating in 11 dimensions. The true wonder is not that the universe is complex, but that this chaos can organize itself into something as stable, as resilient, and as conscious as a human being. We are a masterpiece of quantum engineering, a structure built from ghosts, held together by ancient light, and animated by the flow of the very particles that physics tells us are not really there. The transition from the subatomic to the biological is the greatest magic trick in the cosmos. Down in the basement of reality, the rules are insane. Electrons can be in two places at once. They can tunnel through walls, and they exist only as hazy waves of potential. Yet, as we zoom out, these unruly entities link arms to form the rigid, predictable architecture of life. The bridge between these two worlds, the quantum and the living, is the chemical bond. But a chemical bond is not a physical strut or a drop of glue. It is a relationship between electrons. When a carbon atom in your DNA connects with a hydrogen atom, they are not touching. They are trading. They are playing a game of catch with their outermost electrons, sharing the quantum clouds to fill their energy shells. This sharing creates a force field, a tension that locks the atoms in place relative to one another. The force that holds your body together, that prevents your skin from dissolving into the air and your bones from turning to dust, is the electromagnetic force, and the carrier of this force is the photon, the particle of light. This leads to a staggering realization: you are held together by light. The electrons in your atoms are constantly exchanging virtual photons with the electrons of neighboring atoms, a ceaseless conversation of energy that says, "Stay here, do not let go." The solidity of your body is a web of invisible light woven tight by the frantic motion of particles that have no mass. We are effectively condensed energy, trapped in a stable loop, pretending to be matter. Consider the double helix of your DNA, the twisting ladder that encodes the instructions for every protein, every cell, and every trait that makes you unique. This molecule is the most dense information storage device in the universe, and its existence hangs by a quantum thread. The two strands of the DNA helix are zipped together not by strong covalent bonds, but by something much more delicate called a hydrogen bond. This is a weak attraction, a subtle electrostatic kiss between a hydrogen atom on one side and a nitrogen or oxygen atom on the other. It is strong enough to hold the genetic code together through the violence of cellular life, yet weak enough to be unzipped when the cell needs to replicate or read the instructions. This precise balance is a result of the specific mass and charge of the electron. If the electron were a fraction of a percent heavier, or if its charge were slightly different, the strength of this bond would change. The DNA might zip too tightly to ever be read, or it might fall apart instantly. The entire machinery of life, the ability to copy genetic information, to pass life from one generation to the next, relies on the fine-tuning of these quantum values. We are walking the razor's edge of probability. The stability of our species is a quantum accident, a precarious equilibrium maintained by the specific vibrations of the electron field. Furthermore, we are not just built of electrons, we are powered by them. The very definition of being alive is, in essence, the ability to control the flow of electrons. Every time you take a breath, you are not just sucking in air, you are facilitating a subatomic transfer. Oxygen is an element with a ravenous hunger for electrons. The food you eat, carbohydrates, fats, proteins, is essentially a stockpile of high-energy electrons held in carbon bonds. In the microscopic power plants of your cells, the mitochondria, a complex process called the electron transport chain takes place. This is the engine of life. Your body strips electrons from the food and passes them down a staircase of proteins, extracting their energy step by step, before finally handing them off to the oxygen you breathed in. This controlled fall of the electron, like water spinning a turbine, generates the ATP molecules that power your heartbeat, your muscle contractions, and your thoughts. You are an electrical machine. You are a conduit for electron flow. The warmth of your body is the waste heat from this subatomic friction. When we say a fire burns, it is the rapid, chaotic transfer of electrons to oxygen. Life is simply a slow, controlled, and incredibly complex fire. We are burning, moment by moment, kept alive by the precise choreography of the electron's descent. This perspective recontextualizes our physical form. We often think of ourselves as separate from the inanimate universe, as special observers standing apart from the cold, dead rocks and stars. But the materials that make up this quantum machine are not of our own making. The electrons that dance in your fingertips, the protons that anchor the calcium in your bones, the neutrons that weigh you down, none of them were created in the womb. They are ancient artifacts. The hydrogen in the water of your cells was born in the Big Bang 13.8 billion years ago. It is the original ash of creation. But the heavier elements, the carbon, the nitrogen, the iron in your blood, have a more violent history. The universe began with only simple gases. To make a human, you need complexity. You need the crushing pressure and searing heat of a star. For billions of years, giant stars acted as nuclear furnaces, smashing simple atoms together to fuse them into heavier ones, forging the building blocks of biology in their dying hearts. When those stars ran out of fuel, they collapsed and exploded in supernovae, scattering their enriched guts across the galaxy. The iron that makes your blood red was forged in the final scream of a dying sun. The gold in your ring was made in the collision of neutron stars. We are composed of cosmic debris. We are the nuclear waste of the universe, reorganized into a thinking entity. The electrons that now power your brain may have once swirled in the atmosphere of a gas giant that no longer exists, or ridden the shockwave of a galactic explosion. They are ageless travelers, temporarily conscripted into the service of you. There is a profound humility in acknowledging that we are borrowed structures. We are temporary patterns in the field. Just as a wave rises from the ocean, takes a shape, catches the light, and then crashes back into the water, we are a momentary coherence of the electron field. For a few decades, the swarm of particles agrees to be a person. It agrees to hold the shape of a face, to encode the memories of a childhood, to feel love and anger, and then, inevitably, the coherence fades. The quantum sentinels relax their guard, the chemical bonds loosen, and the swarm disperses, The electrons do not die, they cannot die. They simply return to the field, to the soil, to the air, ready to become part of a leaf, a stone, or another star. We are not the owners of these particles, we are their caretakers. But while we are here, holding this shape, something extraordinary happens. The interactions of these mindless, ghost-like particles give rise to a phenomenon that transcends physics: consciousness. The brain is the most complex arrangement of matter in the known universe. It contains 86 billion neurons, connected by trillions of synapses. And what is a thought? It is an electrical impulse. It is a wave of ions-charged atoms moving across a membrane, driven by the movement of electrons. When you fall in love, when you grieve, when you calculate a math problem or compose a symphony, you are experiencing the macroscopic result of a specific pattern of electron flow. The you that feels and thinks is a user interface running on a hardware of quantum meat. It is a paradox that defies explanation. How can a collection of zeros, a pile of dimensionless points, a swarm of unfeeling vibrations, combine to create a feeling of self? How does the what become the who? Physics can explain the voltage across the neuron, the chemistry of the neurotransmitter, and the frequency of the brainwave. But it cannot explain the redness of a rose or the pain of a heartbreak. This is the hard problem of consciousness. We are ghosts driving machines made of ghosts. The deeper we look into the electron, the more we realize that the solid ground we thought we stood on is a floor made of clouds. And yet, the floor holds. The machine works. We are walking paradoxes. We are vast galaxies of empty space that feel solid. We are made of particles that are timeless. Yet, we are mortal. We are governed by the laws of probability, yet we feel a sense of destiny. We are the universe, looking at itself through eyes made of stardust, using a brain powered by the same force that lights the sun. This biological reality, this breathing, thinking, feeling existence is the ultimate triumph of the electron. It is not just a point on a graph or a knot in a field. It is the brushstroke of reality. The electron allows the universe to be more than just a cold, dark void. It allows for structure, for complexity, for chemistry, and ultimately, for life. The hidden thing inside the electron is not just a string or a dimension. It is the potential for everything that we are. We are the children of the electron, forged in fire, bound by light, and destined to wonder about the tiny, invisible giants that hold us together. In this temporary union of the subatomic and the biological, we find the true majesty of existence. We are the architecture of nothingness, dreaming that we are something. We have reached the end of our journey, a voyage that began not with a rocket launch to distant stars, but with a simple, unassuming act, the touch of a finger against a screen. We started with the familiar, the solid, and the mundane. We looked at the world we thought we knew, the chairs we sit on, the hands we hold, the air we breathe, and we peeled back the surface. Layer by layer, we descended into the basement of reality. We moved from the illusion of contact to the vast, hollow cathedrals of the atom. We witnessed the frantic dance of the quantum sentinels, felt the vibration of strings singing in 11 dimensions, and floated in the infinite ocean of the electron field. We chased a ghost, we hunted for a marble and found a mathematical storm. And now, as we stand at the bottom of this rabbit hole, looking up at the light of the macroscopic world, we are left with a final, lingering question. What does it all mean? The search for the core of the electron was never really about the electron. It was a proxy war for a much deeper campaign, the search for the core of ourselves. When we ask, "What is the universe made of?" we are really asking, "What am I made of?" The answers we found are both terrifying and liberating. We found that, at our most fundamental level, we are not made of stuff in the traditional sense. We are made of relationships. We are made of tension. We are made of probability and light. The I, that you perceive the ego, the identity, the weight of your body, is a miraculous emergent property, a stable pattern arising from a chaotic sea of instability. To understand the electron is to accept that you are a transient masterpiece of the cosmos, a brief moment where the universe has organized its energy into a form that can say, "I am." This journey forces us to confront the limitation of our senses. Our eyes evolved to see predators in the grass and fruit in the trees. They did not evolve to see the quantum foam. We are trapped in the middle world, a narrow slice of perception between the atomic and the galactic. Because of this, we are prone to arrogance. We look at a stone and say it is still. We look at empty space and say it is nothing. We look at ourselves and say we are separate. But physics has given us a second sight. It has taught us that the stone is a buzzing hive of motion, that empty space is a boiling cauldron of potential, and that we are continuous with the fabric of reality. The boundaries we draw are imaginary lines on a map that has no borders. This realization brings us to what we might call the gift of wonder. It is easy to feel small when confronted with these truths. It is easy to feel insignificant when you realize you are 99.999% empty space, composed of particles that are just ripples in a field, living on a rock, circling a nuclear furnace in a vast, dark void. But this is the wrong perspective. The proper response is not nihilism, it is awe. The fact that you exist at all is statistically impossible. The fact that the universe has calibrated the mass of the electron, the strength of the electromagnetic force, and the geometry of space-time to allow for the existence of DNA, of consciousness, and of love, is a cause for celebration. We must remember the message of Theodore, the guiding spirit of our inquiry. He reminded us that the universe is not trying to hide its secrets from us out of malice. It is simply waiting for us to grow tall enough to reach the top shelf. He taught us that the mystery is not a problem to be solved, but a reality to be experienced. The core we sought was not a final destination, but a horizon. Every time we sail toward it, it moves further away, revealing new oceans, new islands, and new stars. This is not a failure of science. It is the promise of eternity. If we had found a little hard ball at the center of the electron, if we had hit a bedrock where the questions stopped, the universe would be a small, finite, and ultimately boring place. It would be a box we could measure and dismiss. But we did not find a box. We found a song. We found strings vibrating in dimensions we cannot see. We found a single traveler weaving the tapestry of time. We found that the universe is deeper, stranger, and more beautiful than our eyes can see. It suggests that reality is not a machine that is running down, but a garden that is constantly blooming. The deeper we look, the more beauty we find. There is no ugly bottom layer, there is no messy scaffolding. Down at the Planck scale, in the heart of the vibration, there is only perfect symmetry and pure mathematics. The foundation of existence is elegance. This perspective shifts how we walk through the world. When you wake up tomorrow and touch the surface of your table, remember the levitation. Remember the electromagnetic repulsion that keeps you hovering. When you see the sunlight hitting the leaves of a tree, remember the photons dying to give their energy to the electrons in the chlorophyll, driving the engine of life. When you look into the eyes of another person, remember that you are looking at another knot in the same field, another localized storm in the same ocean. We are not strangers in this universe. We are its symptoms. We are the way the cosmos knows itself. The search for the electron also teaches us humility. We have built our civilization on the back of this particle. We push it through wires to light our cities. We manipulate it in silicon chips to power our computers. We use it to scan our bodies for disease. We have enslaved the electron, yet we do not fully understand it. We are like children playing with a master's violin, managing to scratch out a tune without understanding the physics of the acoustics or the craftsmanship of the wood. This humility is healthy. It keeps us curious. It prevents us from thinking we have finished the book of nature when we have arguably only read the table of contents. As we conclude this exploration, we must accept that some questions may remain unanswered. We may never see the strings with our own eyes. We may never travel to the 11th dimension. We may never know for sure if we are living in a one-electron universe. And that is okay. The value of the journey was not in the capture of the prize, but in the expansion of the soul. We have stretched our minds to accommodate the impossible. We have learned to hold contradictory ideas, particle and wave, here and everywhere, something and nothing in our heads simultaneously. We have exercised the muscle of imagination. The architecture of nothingness has revealed itself to be an architecture of light. The dimensionless point has revealed itself to be the pivot upon which the cosmos turns. And you, the observer, are the witness to this majesty. You are the universe waking up. You are the place where the falling stone and the rising thought meet. You are the ghost in the machine, but you are also the machine itself, and the fuel and the road. So do not be afraid of the emptiness. Do not fear the void within your atoms. That void is not a lack of existence. It is a space for possibility. It is the room the universe needs to dance. Embrace the uncertainty. Embrace the vibration. Embrace the fact that you are a mystery to yourself. As the great physicists and philosophers have whispered through the ages, the quest for understanding never truly ends. The final answer is always just the beginning of a new question. We close this chapter not with a period, but with an ellipsis, a dot, 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 trailing off into the future, inviting you to keep looking, keep thinking, and keep wondering. The electron will keep spinning, the strings will keep vibrating, and the single traveler will keep weaving its path through time, whether we are watching or not. But it is so much better when we watch. Thank you for taking this journey into the subatomic with me. Thank you for lending your mind to these difficult and beautiful ideas. It has been a privilege to explore the architecture of reality with you. Good night, fellow travelers. Sleep well in this vast, vibrating, and wondrous universe. I will see you in the next video.